Hello everyone. Number systems is a very important topic. Today let's talk about binary, denary and hexadecimal number systems and how to convert in between binary, denary and hexadecimal number systems. In computer science, data representation has a very important role. Binary number system users, let's see first of all. Computers use binary numbers all the time. Computers store data, process data, manipulate in all the ways using binary number system. There is a reason behind it. Inside the computers and electronic devices, we have circuits. The circuits are actually using binary logic gates. Concept is these circuits using logical switches which are having only two states. Those b- switches should be mapped to a number system in order to deal with data. Therefore, with the computers and digital devices, we are using binary number system. It says computers use the binary number system to manipulate and store all of their data, including numbers, words, videos, graphics, and music. The term bit, the smallest unit of digital technology, stands for binary digit. A byte is a group of 8 bits. Binary number system is one of the type of number representation techniques. It is most popular and used in digital systems. Actually, binary number system used in almost all the digital devices. Binary system is used for representing binary quantities which can be represented by any device that has only two operating states or possible conditions. Wherever we have only two states in digital world, we can use binary number system. For example, a switch has two states, open or close, like that. Why computer use binary number system? As I explained you, computer system is a digital electronic device which can understand and execute program instructions communicated in terms of two states on and off. These two states can be best represented using binary number system. That's the reason why we are using binary number system for our electronic devices. We will learn three main number systems and conversions between them: binary number system, denary number system, and hexadecimal number system. Binary number system. As we have discussed, binary number system has only two states: on off, true false, like that. Except two states can be mapped to binary number system. The base is 2. It has only two numbers, 0 and 1. Using these two numbers, almost all the values are represented. The computer system understands only binary number system. Therefore, we need to communicate with the computer only using binary number system. Binary number system alternatively referred to as machine language or machine code. In binary number system, all the numbers are represented by using only two numeric numbers, that is either 0 or 1. The binary number system has base of 2. Because it has only two digits, it represents any number. All computer programs written in any high level programming language must be first converted into machine code in binary that can be directly executed by the computer's CPU. Applications of binary number system. In order to store videos, audios, any type of file, any document inside a digital device, we are using binary number system. It's used in all digital logic, computing devices of all sizes, shapes, and applications. Binary is a fundamental building block of virtually all logic or digital logic. A transistor acting as a switch is either on or off. Combinations of binary digits are used in various ways to build up higher level building blocks like gates, registers, arithmetic processors, etc. Machine language. What is machine language? When we write codes using zeros and ones, that means in binary, that is known as machine language. With very earlier computers, actually all the codes were written in machine language. That is a very difficult task. Only the specially trained people can do that. The machine code is denoted in computers through strings of binary digits. 0 means the absence of voltage, while 1 indicates the presence of voltage. Computers are primarily controlled with the help of electric signals. Therefore, machine language is understood and interpreted by computers swiftly. When we are using high level programming languages like Java, C++, like that, we have to convert those codes into machine code before we run them on the computer. But if we write a particular code in using machine language, that is the native language of the computer. So, no need to convert them. ASCII codes. Computers store in letters, numbers, symbols, and we represent those letters, numbers, symbols in our applications also. There are two coding methods we are using to represent letters, numbers, and symbols. The letters, numbers, and symbols that are represented in a standard keyboard can be represented using ASCII codes. If you need to represent almost any other complex language in the world, like Japanese, Hindi like language, you have to use Unicode. In ASCII codes stand for American Standard Code for Information Interchange, was introduced in 1963. This code specified the method of electronic devices to display various characters, including uppercase and lowercase alphabets of English, numbers, and punctuation symbols. This code was based on strings of 7 bits initially, but with the further extension in ASCII code, the length of strings was set on 8 bits. This extension was due to the addition of characters from foreign languages in ASCII code. If you have to define null in ASCII code, you will represent it by 8 zeros string of bit. Using ASCII, we can represent almost all the characters on a standard keyboard. Then 8 bits will be used to represent it. 7 bits used to represent the character. The 8 bit will be used for error checking. Next, we are moving for denary number system. Denary means decimal number system. Base is 10. We have numbers from 0 to 9. That is a number system that we are using for everyday task. Denary, also known as decimal law base 10, is the standard number system used around the world. It uses 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to represent all numbers. Denary is often constrained with binary, the standard number system used by computers and other electronic devices. The first two letters in denary, the DE or D, are abbreviated version of DEC, which is a Latin prefix meaning 10. The Latin prefix bi means 2. Therefore, the denary system contains 10 digits, while the binary system only contains 2, 0 and 1. Both systems can be used to represent any integer. The table below shows how numbers are displayed in both denary and binary. The table is coming up. The denary number system, denary place values. Using the denary system, 6432 reads 6432. One way to break it down is 6,000s, 400s, 3 tens, 2 ones, like that. Each number has a place value which could be put into columns. Each column is a power of 10 in the base 10 system. In the denary number system, look at this table. Here 6432 is represented using the place values like this. 10 to the power 0 equals to 1, 10 to the power 1 equals to 10, 10 to the power 2 equals to 100, 10 to the power 3 equals to 1000. Any number system, 0th power is 1. That is the base case we are using. Depending on that, other values are represented. Therefore, 6432 can be represented like this. Hexadecimal number system. There is a special factor about it. One hexadecimal number equivalent to 4 binary digits. Therefore, for imagine there is a binary file which is having 100 digits. If you convert that into a hexadecimal number, there will be only 25 digits. That will shrink in the values drastically. Therefore, in order to represent long binary values in different places, we use hexadecimal number system. Hexadecimal is a base 16 number system. Base 16, so when we represent numbers, we take 0 to 9 from decimal number system, and in order to represent 10 to 15, we are using English capital letters from A to F. That's the specialty of hexadecimal number system. It is a different method of representing numbers than the base 10 system we use in everyday practice. In base 10, we count in multiplies of 10 before adding another digit. For example, 8, 9, 10, 11, 12, like that, 98, 99, 100, 101, 102. Notice how a new digit is added when the number 10 is reached, and another digit is added to represent 100. 10 into 10. In base 16 or the hexadecimal number system, each digit can have 16 values instead of 10. The values of hexadecimal digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, in order to represent 10, capital A, then 11b, like that. 10 to 15 we represent using A, B, C, D, E, F. So wherever you have 10, 11, 12, 13, 14 or 15, you have to use capital English letters from A to F. While computers process numbers using base 2 or binary system, it is often more efficient to visually represent the numbers in hexadecimal format. This is because it only takes one hexadecimal digit to represent 4 binary digits. Since there are 8 binary digits in a byte, only 2 hexadecimal digits are needed to represent 1 byte. Now we have to talk about number conversions. That's a very interesting topic. Let's talk about it. Binary, the base 2 numbering system. Let's see how can we convert numbers in between binary to denary, denary to binary, and in between hexadecimal also. In the decimal number system, we saw that 10 numerals were used to represent numbers from 0 to 9. Binary only uses two numbers, 0 and 1. Placeholders in binary each have a value of power of 2. So the first place have a value 2 to the power 0 equals to 1. The second place 2 to the power 1 equals to 2. The third place 2 to the power 2 equals to 4. The fourth place 2 to the power 3 equals to 8, and so on. In binary, we count 0, 1, and then since there's no numeral for 2, we move on to the next placeholder. So 2 is written as 10 binary. This is exactly the same as when we get to 10 decimal and have to write it as 10 because there's no numeral for 10. In binary number system, you should have a proper idea, proper understanding regarding the place values. 2 to the power 0 equals to 1. As I told you, any number system, 0th power equals to 1. Depending on that, other values we are generating. 2 to the power 1 equals to 2, 2 to the power 2 equals to 4, 2 to the power 3 equals to 8, and so on. It's going on. Every time that is the value is multiplying by 2. Normally we are doing conversions for 8 bits. So it's normally we are using from 2 to the power 0 to 2 to the power 7, but for some calculations we need further values also. Most significant bit and the least significant bit. When doing calculation, you should have a proper understanding regarding most significant bit and the least significant bit. In a binary number, leftmost bit is known as most significant bit. It has the highest value. In a binary number, rightmost bit is known as the least significant bit. It has the least value. In a binary number, the most significant bit is the digit furthermost to the left of the number, and the least significant bit is the rightmost digit. Step 2. Convert from decimal to binary. Write down the decimal number. Then divide the number by 2. Successively divide the number by 2. Write the result underneath. Write the remainder on the right hand side, aligned to the value. This will be either 0 or 1. Divide the result with the division by 2 and again write down the remainder. Continue dividing and writing down remainders until the result of the division is 0. Please go up to 0. Don't finish it up in by the way. The most significant bit is at the bottom of the column of remainders and the least significant bit is at the top. Read the series of ones and zeros on the right from the bottom up. This is the binary equivalent of the decimal number. Decimal to binary conversion. Look at this conversion example. In this example, the number 29 we are dividing by 2 again and again until we reach 0. Let's look at the example now. 29 divided by 2, answer is 14. If you can directly get the answer, do it like that. Otherwise, number by number you can divide. 29, 2 divided by 2, 1. 9 divided by 2, 4, and remaining 1. That is totally fine. 14 divided by 2, 7, remaining 0. 7 divided by 2, 3, remaining 1. 3 divided by 2, 1, remaining 1. 1 divided by 2, 0, remaining 1. So now the answer from bottom up you have to consider, because this last value is the most significant bit, above value is the least significant bit. So when you write from bottom up, 11101 in binary is equivalent to 29 in denary. Another example given in 47, 47 divided by 2 again and again. And when you come up with until 0, you can write bottom up. 47 divided by 2, 23 remaining 1. 23 divided by 2, 11 remaining 1. 11 divided by 2, 5 remaining 1. 5 divided by 2, 2 remaining 1. 2 divided by 2, 1 remainder 0. 1 divided by 2, 0, and remaining 1. Now write bottom up. 1011111 into 2 equal to 47 in denary. Decimal to binary conversion. Another example is given here. You can see like this is 4215 converting into a binary number. There are a lot of steps involved, but still number by number you can divide accurately, and then you can come up with the correct answer. There is another method to convert decimal number to a binary using place value method. In that method, how to do is, here we have to convert number 25 into binary. If you have to convert number 25 into binary, what you can do is, you can write the place values or the powers of 2 both up to 25. Actually, it's better to write one value larger than the given value, then accurately you can get the value without any problem. So I'm writing 2 to the power 0 equals to 1, 2, 4, 8, 16, and after that 32. Now 32 is exceeding 25, so that's enough to write up to 32. Now identify what are the numbers from 1 to 32 in the list, what are the numbers you need to add in order to create number 25? Here, when you add some numbers, you can create 25. Do you need 32 to create 25? No, then put 0. Can you use 16 to create 25? Yes, you can create. Put 1. Can you use number 8 to create 25? Let's check that. 25 minus 16. We have used that. Now subtract and see how much remaining. 9 is remaining. 9 is remaining. So you can use 8 to create 9 now. So use 1 here. Then when you use number 8, 9 minus 8, only 1 remaining. So you don't want 4 or 2. You only need 1. So answer is 11001. Mention 1 below the place values when you need to add that number to make the given number. In this example, to make 25, need to add 16, 8 and 1. You should start with the nearest small number to the given number. Here 16. Another example is given here, converting number 59. When you are converting number 59, you have to write 1, 2, 4, 8, 16, 32 values that only will be needed. So if you write one value larger than that also, that would be fine. Anyway, the up to that value that you are using, or maybe one value larger than that, you can write. Then identify what are the numbers to be added, subtract and see. Then you will identify we need 32, 16, 8, 2 and 1 in order to create number 59. Represent binary numbers as one byte. So when you convert number 59 into binary, you will get this number 111011, that is 6-digit number. So when you need to represent it in computer science, in most of the time our registers that we are using will be 8 bits, 16 bits like that. So normally we represent answers in 8 bits. Then what you need to do is, here we have 6 bits, add zeros to the left side in order to make it a 8 bit. When adding zeros to the left side, that won't change the value. There are some questions you can try out. Answers also here. Now let's talk about binary to decimal conversion. That is a very important number conversion that we have to consider. In binary to decimal conversion, you have to write the binary number and then you have to write 2 to the powers and the place values like this. You can write it above the number or beneath the number. Then you have to multiply the place values with the number and need to write it. 32 into 1, 32 plus 16 into 0, 0, 8 into 0, 0, 4 into 1, 4, 2 into 0, 0, 1 into 1, 1. Then add the values and you'll end up with the result 37. Here are some exercises that you can try out. Here, decimal to hexadecimal conversion. Decimal to hexadecimal conversion also very important. Let's look at it now. When you convert decimal numbers to hexadecimal or hexadecimal to decimal, you have to have a very good idea about the numbers from 10 to 15. We are considering 10 to 15, but we don't write them. We write the equivalent letters of the 10 to 15. 10 equals to A, 11 equals to B, 12 equals to C, 13 equals to D, 14 equals to E, and 15 equals to F, like that. When we convert number 450 into a hexadecimal number, first we have to divide it by 16. Successively divide by 16 until we reach 0. 450 divided by 16, answer is 28 and remaining 2. 28 divided by 16, answer is 1 and remaining 12. We don't write 12, instead we write capital letter C. 1 divided by 16, answer is 0 and remaining 1. Then we can write 450 into base 10 equals to 1C2 into base 16. There is another example 910 converting into hexadecimal number. 910 divided by 16, answer is 56 and remaining 14. Without writing 14, we write capital E. 56 divided by 16, answer is 3 and remaining 8. 3 divided by 16, answer is 0 and remaining 3. Therefore, 910 into base 10 equals to 38E into base 16. Here are some examples that you can try out. Actually, in order to understand these number conversions, you have to try out a lot of examples. Now let's talk about hexadecimal to decimal number conversion. That is also a very important number conversion that we have to consider. Here in hexadecimal to decimal number conversion, we can see this example convert 1F4 into 16 into a decimal number. When we consider that number, what we can do is we can write powers of 16. 16 to the power 0 equals to 1, 16 to the power 1 equals to 16, 16 to the power 2 equals to 256, 16 to the power 3 equals to 4096. Then what you can do is you can write the hexadecimal number 1F4 underneath the place values. Then you have to multiply the results and add. Here 256 multiplied by 1 plus, then here 15 multiplied by 16 plus 4 into 1 plus. Then when you add these values together, you end up with the decimal number, that is 500 into base 10. There are some examples that you can try out. Binary to hexadecimal number conversion. When you have a binary number convert into a hexadecimal number, first write your number and then divide your number into 4-bit sections from right hand side to left hand side. If you have exactly 4-bit sections, then no problem. But if you don't have, actually in the leftmost group there can be 3 bits, 2 bits or 1 bit. Then add zeros to the left side to make it a 4-bit section. Then separate it, write down the 4-bit sections. Underneath write down 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 in each group. Then write the place values 1248, 1248 under each group. After that, wherever you have value 1, add that. Here you have value 1, place value 8 plus here value 0 plus here value 1, therefore 2 plus here value 1, therefore 1 plus, like that. You can multiply and add also. So when you add the values in the first group, value is 11. Therefore, we consider the letter capital B. Here value is 7. So answer is B7 into base 16. Find the hexadecimal values of the following binary numbers. You can try out these exercises and see whether you can do these exercises. Hexadecimal to binary conversion. Hexadecimal to binary conversion also a very important number conversion. What you need to do is here you can get the value 3AB2 like this. Then what you can do is you can separately write these values with some space. After that, under each of the group, write down 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. After that, write down the place values also under each group. Then after that, what you need to do is you can multiply and add the values, or else here, whatever the values you need, the best method here is without trying out the different ways. Here, in order to create number 3, what are the values to be added? In order to create number 10, what are the values to be added? In order to create number 11, what are the numbers to be added? Like that you can consider. Here, in order to create number 3, you need to add 2 plus 1. Okay, therefore you have to consider 2 and 1. When you are using 2 and 1, write number 1 underneath. Here add zeros for 8 and 4 there because you are not using them. Here, in order to create number 10, you have to consider adding 8 into 2. So write down number 1 underneath 8 and 2. Here 4 and 1 we are not using, so write number 0. Then after that, in order to create letter B, that means number 11, you need to add 8 plus 2 plus 1. Since you are using 8, 2 and 1, write number 1 under them and 0 under number 4. In order to create number 2, we have 2 here. Just write number 1 underneath number 2. Here then it will be 8, 4 and 1 zeros. So these are separate groups. Finally, write them down as one binary string. Then your answer is perfect. Here are some exercises that you can try out. I hope you understood decimal, binary, and hexadecimal number systems and how to convert numbers in between decimal, binary, and hexadecimal number system. See you soon with another computer science video. Have a nice day.